Students, in the previous video, we saw what is filter and their classification. So many classifications, so many number of filters are there. But as I have told you, for your syllabus, there is only a passive filter and constant K filters. I am talking about passive filters. What do we mean by passive filters? Passive filters are nothing but the filters which are having only the passive components like L and C. So, filter is nothing but a circuit now. If I ask you to draw any filter circuit, that too passive filter circuit, you should show a combination of L and C, that's all. Only two components in the filter circuit. So, further these passive filters are classified as low pass filter, high pass filter, band pass filter and band stop filter. Low pass filter, high pass filter, band pass filter, band stop filter. Band stop filter can also be called as band elimination filter BEF or band reject filter BRF. There are three names for the last type of passive filter: band stop, band elimination or band reject. So these are the four types of passive filters we have. Next, we will see the characteristics of these low pass filter. So, taking up this characteristics, this is called low pass filter characteristics. So, what this is a graph, what we are showing? We are showing frequency versus attenuation, means for the frequencies, for these frequencies, is there any attenuation offered by the filter? Is there any attenuation offered by the filter? Means it is offering zero attenuation or infinite attenuation, that we have to talk. Zero attenuation means no stop, no loss of the signal, means the filter is passing all the signals. Infinite attenuation means filter is not at all passing any of the signals, that is attenuation 0 and attenuation infinite. So here these are the range of frequencies. I have written here 0, then you can imagine the frequencies as F1, F2, F3 and all. Here FC I have written to indicate that this is cut off frequency which is separating pass band and stop band. PB is pass band, SB stands for stop band. This is cut off frequency FC, which we have defined in the previous video. Now, what we can talk about this low pass filter means this is a low pass filter. What it is doing is this filter is allowing the transmission of all the signals below the cutoff frequency. Below the cutoff frequency, that is 0 to FC, there are so many signals having these frequencies. You can imagine, suppose FC is 10 kilohertz. Suppose the value of FC is 10 kilohertz and here the frequencies are having 0, 1K, 2K, 3K, 4K up to 10K. So all these signals are passing through the filter, means at the output of the filter we are getting the signals which are having only these frequencies, and at the output of the filter we are not getting the signals having these frequencies, that is beyond FC, means beyond 10 kilohertz. Even if it is 10.5 kilohertz also we should not get at the output. So 10, 20, 30, 40 kilohertz signals are stopped from passing through the filter. So what is this low pass filter? Low pass filter passes the transmission of the signals only varying from 0 to FC. In this it has got zero attenuation, whereas filter has to have infinite attenuation beyond FC, means beyond FC, after FC, the signals are not allowed to pass through the filter. This is low pass filter. Low pass, lower the cutoff frequency. Lower the cutoff frequency, all signals are passed, therefore this is pass band. Reverse of this one is high pass filter. You can see here, this is high pass filter. What it is doing, same thing, attenuation we have shown, and this frequency also we have shown here. Here this is cutoff frequency FC. This is cutoff frequency FC. What we are doing here is, this is high pass filter, means this filter will pass all the signals which are greater than this cutoff frequency. Means FC, if it is 10 kilohertz as in the previous case, from this filter at the output we are getting the signals which are having the signals 10 kilohertz and more than 10 kilohertz, all signals we are getting. So therefore this is pass band, whereas below this 0 to FC we are not getting any signals, therefore it is called stop band. So what this filter will do, this filter will pass all the signals which are greater than cutoff frequency, but below the cutoff frequency no signals are passed. So filter has high attenuation here, it has zero attenuation in the pass band. So low pass means lower the cutoff frequency, all are passed. High pass means higher the cutoff frequency, all signals are passed. Similarly, next, by the name itself you can understand this is band pass filter. Band pass means particular band of frequencies are, only the particular band of frequencies are allowed to pass through the filter. Here filter allows only this particular band of frequencies. Means suppose this is F5, FL I have shown, FH I have shown. Again this is frequency and the attenuation. Instead of showing one cutoff frequency, we have shown two cutoff frequencies. You can call this one as FC1, cutoff frequency 1, FC2, cutoff frequency 2. Otherwise FL, FH, that is lower cutoff frequency, higher cutoff frequency also you can take. So suppose the value of this one is 5 kilohertz, value of this one is 10 kilohertz. What my filter will do, it will allow the transmission of the signals whose frequency is somewhere in between 5 kilohertz to 10 kilohertz. It will allow 5 kilohertz, yes. 5.5, yes. 6, yes. 6.5, 7, 8, 9, 10 it will pass. Whereas if you come to 10.1 kilohertz also, it should not pass. So it is particularly allowing the transmission of a particular band of frequencies varying from FL to FH. Here the filter should have attenuation. What amount of attenuation? 0 or infinite? It has to pass the signals without any loss, means attenuation should be 0 in this band, whereas attenuation should be infinite in these bands, because below FL and beyond FH, FL से नीचे FH के बाद no signals are allowed to pass through the filter. Reverse of this one is band elimination filter, band stop filter or band reject filter. What we will do in that is, this will make it as a stop band, these two bands will be pass band. You can see here. Alright, here how we can explain is, this filter will not allow this particular frequencies to pass through it. 5 kilohertz, 10 kilohertz, 5 kilo not passed, 5.1 not passed, 5.2 not passed, 5.9 not passed, 6, 6.5, 7, 8, 9, 10 kilohertz. These are not allowed to pass through the filter, but the frequencies, the signals which are having the frequency less than 5 kilohertz, that is less than this FL, 1 kilo, 2 kilo, 3 kilo, 4 kilo, everything we are getting at the output. Similarly, 20, 30, 40, 15, 22, 21, all those frequencies we are getting. So, particular band of frequency falling in between FC1, FC2 or FL and FH are not allowed to pass through the filter, but below FL all signals are allowed to pass, and beyond FH all signals are allowed to pass in case of band pass filter. And this filter has, here in the stop band means high attenuation in this band, whereas zero attenuation in this band. This is all about the ideal characteristics of passive filters. Thank you.